Firstly, check the GFCI breakers themselves. Confirm that the GFCI breakers are compatible with the electrical system and equipment. Ensure the breakers are properly installed in the panel and are tightened securely. Check for any visible damage or corrosion on the breakers. Secondly, inspect the wiring. Use a voltage tester or multimeter to check for continuity and proper wiring in all outlets and devices on the circuits. Look for any loose or broken wires, especially at the receptacles and switches. Ensure the grounding wires are properly connected at all outlets in the electrical panel. Thirdly, test equipment and devices. Try plugging in different types of devices and tools in the circuits to see if the tripping issue persists. Rule out any faulty devices or equipment that may be causing the GFCI breakers to trip. Fourthly, check for moisture or water. Inspect outdoor receptacles and devices for any moisture or water damage. Confirm that the electrical boxes are weatherproof and sealed properly to prevent water ingress. Fifthly, examine conductors. Verify that the wires used in the circuits are of the correct size and type. Ensure that the conductors are not overloaded or damaged. Sixthly, consider electromagnetic interference or EMI. If the circuits are near high power equipment or heavy electrical loads, EMI could cause false tripping of the GFCI breakers. Try disconnecting or relocating the equipment to see if it affects the tripping issue. Also reset the GFCI breakers several times to see if the tripping problem resolves itself. Consult the manufacturer's instructions for specific troubleshooting procedures related to the particular GFCI breakers being used. If the problem persists despite these steps, it's recommended to contact a qualified electrician for further diagnostics and repairs. When dealing with GFCI breakers that trip immediately upon any load being applied, a systematic approach to troubleshooting is essential. The first step involves a thorough examination of the GFCI breakers themselves. It is crucial to confirm that the breakers are indeed compatible with the electrical system's voltage and amperage, as well as the specific equipment intended to be used in the circuits. Mismatched breakers can lead to nuisance tripping or, in more severe cases, damage to the electrical system. Verify the proper installation of the breakers within the electrical panel. Ensure that they are securely seated and that all connections are tightened to the manufacturer's specifications. Loose connections can create resistance, generating heat and potentially causing the breaker to trip prematurely. A visual inspection of the breakers for any signs of physical damage, such as cracks, melted plastic, or corrosion, is also vital. Any such damage can compromise the breaker's functionality and necessitate replacement. Once the breakers have been assessed, the next focus should be on inspecting the wiring throughout the affected circuits. Begin by using a voltage tester or a multimeter to check for continuity and proper wiring at all outlets and devices connected to the circuits. This step helps identify any shorts, open circuits, or miswired connections that could be causing the GFCI breaker to trip. Pay close attention to receptacles and switches, as these are common points where wiring issues can occur. Carefully examine the wires for any signs of looseness, breakage, or damage to the insulation. Loose wires can create intermittent connections, while broken wires can disrupt the flow of current. Damaged insulation can expose the conductors, increasing the risk of shorts and ground faults. Ensure that the grounding wires are properly connected at all outlets and back at the electrical panel. A proper ground connection is essential for the safe operation of GFCI breakers, as it provides a path for fault current to flow back to the source, causing the breaker to trip and energize the circuit. Next, proceed to test various pieces of equipment and devices in the affected circuits. Plug in different types of devices and tools, one at a time, to see if the tripping issue persists. This process helps rule out any faulty devices or equipment that may be drawing excessive current or introducing ground faults into the system. Start with simple devices, such as lamps or phone chargers, and gradually move to more complex equipment, such as power tools or appliances. If a particular device consistently causes the GFCI breaker to trip, it is likely the source of the problem and should be repaired or replaced. Moisture or water intrusion can also cause GFCI breakers to trip, particularly in outdoor or damp environments. Thoroughly inspect all outdoor receptacles and devices for any signs of moisture or water damage. Look for corrosion, rust, or water stains which can indicate that water has entered the electrical components. Verify that the electrical boxes are weatherproof and properly sealed to prevent water from entering. Ensure that any covers or gaskets are in good condition and provide a tight seal. If moisture is found, dry out the affected components thoroughly and reseal the enclosure to prevent future water intrusion. Examine the conductors used in the circuits to ensure that they are of the correct size and type for the intended application. Refer to the National Electrical Code or NEC Table 310.15b16 for the appropriate conductor ampacity based on the wire gauge and insulation type. Undersized conductors can overheat when carrying heavy loads, leading to insulation damage and potential ground faults. Verify that the conductors are not overloaded, meaning that they are not carrying more current than their rated ampacity. Overloading can cause the conductors to overheat and potentially trip the GFCI breaker. Check for any signs of damage to the conductors, such as cuts, abrasions, or melted insulation. Damaged conductors can create shorts or ground faults, causing the breaker to trip. In some cases, electromagnetic interference or EMI can cause false tripping of GFCI breakers. If the circuits are located near high-power equipment or heavy electrical loads, EMI may be present. Try disconnecting or relocating the nearby equipment to see if it affects the tripping issue. Shielded wiring or filters can also be used to reduce the effects of EMI in the circuits. As an additional measure, try resetting the GFCI breakers multiple times to see if the tripping problem resolves itself. Sometimes, a temporary surge or transient voltage can cause a breaker to trip, and resetting it may restore normal operation. Consult the manufacturer's instructions for specific troubleshooting procedures related to the particular GFCI breakers being used. The manufacturer may have specific recommendations or diagnostic tests that can help identify the cause of the tripping issue. If the problem persists despite these troubleshooting steps, it is recommended to contact a qualified electrician for further diagnostics and repairs. A qualified electrician has the expertise and tools necessary to safely and effectively diagnose and repair electrical problems. They can perform more advanced testing, such as insulation resistance testing or ground fault loop impedance testing, to pinpoint the source of the tripping issue. They can also ensure that the electrical system is in compliance with all applicable codes and regulations. When troubleshooting GFCI breakers, safety should always be the top priority. Work on electrical circuits should only be performed by qualified individuals who are familiar with electrical safety procedures. Always de-energize the circuit before working on any electrical components, and use appropriate personal protective equipment or PPE, such as insulated gloves and safety glasses. Ground fault circuit interrupters or GFCIs are designed to protect people from electrical shock by detecting ground faults, which are unintended electrical paths between a live conductor and ground. When a ground fault is detected, the GFCI quickly trips, interrupting the flow of electricity and preventing a potentially fatal shock. GFCI breakers are commonly used in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. They provide a higher level of protection than standard circuit breakers, which only protect against overloads and short circuits. SI breakers, on the other hand, protect against arc faults, which are dangerous electrical discharges that can cause fires. SI breakers are designed to detect the unique characteristics of arc faults and trip the circuit before a fire can start. Arc faults can occur due to damaged wiring, loose connections, or faulty appliances. SI breakers are typically required in bedrooms and other areas where people sleep, as they provide an extra layer of protection against electrical fires. The NEC requires the use of GFCI protection in various locations, including bathrooms, kitchens, garages, outdoor areas, and crawl spaces. The specific requirements vary depending on the type of occupancy and the location of the electrical equipment. It is important to consult the NEC or a qualified electrician to ensure that GFCI protection is provided in all required areas. When installing GFCI breakers, it is important to follow the manufacturer's instructions carefully. The breaker should be installed in a dry, accessible location and should be protected from physical damage. The wiring connection should be tight and secure, and the breaker should be properly grounded. After installation, the GFCI breaker should be tested to ensure that it is functioning properly. This can be done by pressing the test button on the breaker, which should cause it to trip. If the breaker does not trip, it should be replaced. GFCI receptacles are an alternative to GFCI breakers. GFCI receptacles provide GFCI protection at the point of use, while GFCI breakers provide protection for the entire circuit. GFCI receptacles are commonly used in areas where only a few outlets need GFCI protection, while GFCI breakers are used when multiple outlets on a circuit need protection. When troubleshooting electrical problems, it is important to have the right tools and equipment. A voltage tester is essential for checking for the presence of voltage and ensuring that circuits are energized before working on them. A multimeter can be used to measure voltage, current, and resistance, which can help identify electrical problems. A wire stripper is used to remove insulation from wires without damaging the conductors. A screwdriver is used to tighten and loosen screws on electrical components. Pliers are used to grip and manipulate wires. And safety glasses and insulated gloves are essential for protecting yourself from electrical shock and other hazards. It's also important to remember that electrical work can be dangerous, and it should only be performed by qualified individuals who are familiar with electrical safety procedures. Always to energize circuits before working on them and use appropriate personal protective equipment. If you are not comfortable working on electrical circuits, it is best to contact a qualified electrician for assistance. Electrical codes and regulations are constantly evolving, so it is important to stay up to date on the latest requirements. The NEC is the most widely used electrical code in the United States, and it is updated every 3 years. States and local jurisdictions may also have their own electrical codes and regulations, so it is important to check with your local authorities to ensure that you are in compliance. GFCI breakers are an essential safety device that can help prevent electrical shock. By understanding how they work and how to troubleshoot them, you can ensure that your electrical system is safe and reliable. Remember to always prioritize safety when working on electrical circuits, and contact a qualified electrician if you have any questions or concerns. When addressing GFCI breaker tripping issues, it's important to consider the potential impact of neutral ground faults. A neutral ground fault occurs when there is an unintended connection between the neutral conductor and the grounding conductor. This can happen due to damaged wiring, improper connections, or faulty appliances. GFCI breakers are designed to detect imbalances in current between the hot and neutral conductors. If a neutral ground fault is present, it can cause a portion of the neutral current to flow through the grounding conductor, creating an imbalance that the GFCI breaker detects, causing it to trip. To check for neutral ground faults, you can use a multimeter to measure the voltage between the neutral and ground conductors. Under normal circumstances, the voltage between neutral and ground should be very low, typically less than 1 or 2 volts. If the voltage is significantly higher, it indicates a potential neutral ground fault. Identifying and correcting neutral ground faults can be challenging, as the source of the fault may not be immediately obvious. It often requires careful inspection of the wiring and equipment connected to the circuit. Look for any signs of damage to the wiring, such as cuts, abrasions, or melted insulation. Check the connections at all outlets, switches, and appliances to ensure that they are tight and secure. If you suspect that an appliance is causing the neutral ground fault, try disconnecting it from the circuit to see if the tripping issue resolves. If you are unable to locate the source of the fault, it is best to contact a qualified electrician for assistance. In addition to neutral ground faults, another potential cause of GFCI breaker tripping is excessive leakage current. All electrical devices have some amount of leakage current, which is a small amount of current that flows from the live conductors to ground. Normally, leakage current is not a problem, but if it becomes excessive, it can cause GFCI breakers to trip. Leakage current can be caused by a variety of factors, including damaged insulation, moisture, and contamination. Older appliances and devices may also have higher levels of leakage current than newer models. To check for excessive leakage current, you can use a leakage current clamp meter. This device measures the amount of current flowing through the grounding conductor. If the leakage current exceeds the GFCI breaker's trip threshold, it will cause the breaker to trip. The trip threshold for most GFCI breakers is 5 mA. Reducing leakage current can be achieved by replacing older appliances with newer, more energy-efficient models. Ensure that all electrical equipment is properly grounded and that the grounding connections are tight and secure. Keep electrical equipment clean and dry to prevent contamination and moisture buildup. And inspect wiring regularly for signs of damage such as cuts, abrasions, or melted insulation. Another important consideration when troubleshooting GFCI breakers is the potential for shared neutrals. A shared neutral occurs when two or more circuits share the same neutral conductor. This is generally not permitted by the NEC as it can create a dangerous situation. When circuits share a neutral, the neutral conductor may become overloaded, leading to overheating and potential fire hazards. Additionally, shared neutrals can cause GFCI breakers to trip due to imbalances in current flow. To check for shared neutrals, you can use a multimeter to measure the current flowing through the neutral conductor. With all circuits energized, the current flowing through the neutral conductor should be approximately equal to the sum of the currents flowing through the hot conductors. If the current is significantly higher, it indicates a potential shared neutral. Correcting shared neutrals typically involves separating the circuits and providing each circuit with its own dedicated neutral conductor. This may require rewiring the electrical system, which should only be performed by a qualified electrician. In addition to the above troubleshooting tips, it is also important to consider the age and condition of the GFCI breakers themselves. GFCI breakers have a limited lifespan and may eventually fail due to wear and tear or component degradation. Over time, the sensitivity of the GFCI breaker may decrease, making it more likely to trip unnecessarily. If you suspect that a GFCI breaker is faulty, it is best to replace it with a new one. When selecting a replacement GFCI breaker, be sure to choose one that is compatible with your electrical system and meets all applicable codes and regulations. It is also a good idea to purchase a high-quality GFCI breaker from a reputable manufacturer. Regularly test GFCI breakers to ensure that they are functioning properly. The NEC requires that GFCI breakers be tested at least once a month. To test a GFCI breaker, simply press the test button on the breaker. The breaker should trip immediately, interrupting the flow of electricity to the circuit. If the breaker does not trip, it should be replaced immediately. By following these troubleshooting tips and maintaining your GFCI breakers, you can ensure that your electrical system is safe and reliable. Remember to always prioritize safety when working on electrical circuits, and contact a qualified electrician if you have any questions or concerns.